That's right, it is time for another How Much Has That Printer Broken After So-and-so Months video, and we're revisiting the Snapmaker U1 after 5 months and over 1,000 hours in. And, well, it's only a little bit broken. Tool changers and, in general, multi-material printing is no longer a curiosity. It is fast becoming the standard. And this was essentially the first commercially oriented, affordable tool changer. And yeah, it is affordable. €850 for a tool changer. Prusa XL was a lot more. And it's affordable now, but probably won't be for long. As much as I would love to spend an entire video about the adoption of tool changers across the industry, this video is about how the last 5 months have gone with the U1. And it's been rocky, but it's been pleasantly rocky. This printer is still being used, it's still printing almost every day, and those of you who have watched this series will know that we have limited space in the office, so if there's something that I don't like or if it's not working properly, then it goes to the faraway land known as the space outside the lab. I like this printer, I need it, and I have no intention of letting someone take it away from me. Philip. To start off, we have to consider the quality of the prints that we were getting immediately after we got this printer, and they were fine. There was nothing to rave home about, but there was nothing to be majorly upset about. However, over time, I was not that happy because in order to get flawless results, I was still going back to other printers like our bamboo printers. I wanted to get more out of it. So more hardware calibration and profile tuning was due. Firstly, the offset, so some layers tended to jut out more. Turns out things were not quite as tight as I would have liked them to be. It was literally that simple, turning screws on the hot end, running the initial calibrations, and doing the belt tensioning, which is a very easy process. You don't really need to tighten anything, just move the tool head back and forth. And things got so much better. We did the capybara print again, and yeah, you can see the difference. One thing I occasionally noticed with some prints, which I absolutely hated, was this weird roughness. Some of you might recognize this, it happens to all printers, but with the U1 it is a bit more noticeable. This is what happens when you print very low layer heights with a pretty low speed, and this was happening more and more often when I was printing full spectrum prints. So I was printing at 0.08mm layer heights. And it can happen sometimes with tool changers more because there is low pressure in the hot end after a tool change. That's where a prime tower is necessary. That actually wasn't the cause here, the prime was working totally fine. The problem was an aberration with the settings I chose in combination with the hardware. The issue is clear when you print something at low speed but print the prime tower at higher speed. Rough parts on the low speed and nice parts on the higher speeds. And there is an obvious quick fix to this. You speed up your prints. The seams were also looking kinda gross and extending artifacts beyond it to the right. That doesn't look good, and while ringing is minimal, it is there, most notably on the y-axis of course. It's more a problem if you have a bad seam because pressure advance was not dialed in properly. Pressure advance calibration does work pretty well though. The only problem is you can't see it in Snapmaker Orca, but you can see it in Orca in the fluid terminal. Not feeling deterred by the seam problem and noticing the lines followed a 2mm spacing, I decided to do a VFA test, and we have the normal low speed spike, but we also have a resonance bump starting at around 120mm per second and ending at around 160mm per second, which happens to be the outer wall speed of the small cylinder test I did, so I used one of Orca's little known features to see if it would help. This is resonance avoidance. You add the speed range you wish to avoid and it avoids them. I don't want to see that resonance at 150mm per second, so I add that speed in, do the test again, and it's considerably reduced. Keep in mind that using this feature will cause your speeds to be over or below the excluded range, so you might have to change your acceleration settings to get the desired speed. And it's not going to completely eliminate it. Your printer still needs to accelerate from a low speed to a high speed, so it can't fully eliminate those speeds in all cases. Accelerating from rest to 160mm per second at the default outer wall acceleration takes 2.5mm, so you'll always have a bit unless you increase your acceleration settings. On that note, I wish Orca and Snorka and all other Forcas would include an actual speed in the preview info like Prusa Slicer does. It's just easier to visualize. Okay, now to more hardware things. So, you remember in the video that we did, one of the spool holders just kept breaking. That keeps happening. Now, it's easy to put back. It's not a big deal, I guess, but it is irritating that it keeps happening, and I'm seriously considering moving to printed spool holders. There seems to be quite a selection of user-made spool holders online. Maybe it's a common problem. Also, and this one is a lot more irritating, those feeders that auto-load your filament, I've had a serious problem with them, and it's only started recently. They seem to be causing a lot of drag on the filament during extrusion. Auto-loading works totally fine, but during a print they can create drag, and sometimes a lot of drag. Temporarily, I have bypassed the feeders. They're no longer going into the feeder and being pushed by the drive gear. They're going straight into the PTFE tube and into the tool head. And you can very easily turn off the feeders via the printer menu, and that disables the auto feeding. We're in touch with Snapmaker to see what can be done here. Unfortunately, right now, I'm not entirely sure what the problem is, but we'll keep you updated. I'm also gradually getting used to how constrained the chamber is. When I started using the printer, I would constantly hit the build plate against the walls. Yes, I am that poorly coordinated, but I'm getting used to it. In our video, we also had bed adhesion issues, notably with PETG, and that might seem weird at first. PETG is a very sticky filament, but in fairness, the direction change on those prints was very sharp, and that's what was causing the problem. Our issue isn't that bad. It's mostly just popping up in special circumstances, like when using PETG and you're printing a very sharp corner. And I said it might seem weird at first because PETG is so sticky, it shouldn't have this problem, but actually PETG can tend to pull up preceding layers when there is a sharp change in direction. And we actually did a video about this, and if you want to check it out, you can see it. It is linked below. I've had no nozzle clogs with this printer, save for two situations. One was some very old PVA filament, and the other was some wet and brittle filament. So I can't fault this to the printer. Well, okay, when I was trying to get TPU working with this printer, there was occasional extruder clogs, but no nozzle clogs. No nozzle clogs. Luckily, adjusting tension on the extruder gear is actually a very, very simple task. But after tuning, I have had good success with TPU. We've printed 95A a lot, and we've had great results with that. But we've also printed down to 30D, which is considerably softer, and that prints like a dream as well. One of my favorite prints with TPU so far has been this print-in-place slingshot. So it's really hard to do this with a printer that is not a tool changer or a nozzle swapper. You can't do this with an AMS, and it's awesome. It's the best toy I've ever made, actually. Despite the rocky nature of my first few months with this printer, I honestly do like using it. If it was any other printer, I might be discouraged, but learning about the pros and cons of this printer has been an enjoyable experience. And I'm happy to say I can now affectionately name it Julius Caesar. But Snapmaker, despite being trailblazers in the toolchanger realm, now sort of have an uphill battle because Index is pretty much already out, and there are all those Chinese Index clones that are coming to market soon. The main difference between the U1 and an Index is the passive tool. These are small, and you can fit 8 of these Index tool heads into a Prusa Core 1, which is a printer that is considerably smaller than the U1, which has 4. With the coming of full spectrum, there is a greater demand for extra tools. CMYK, just 4 filaments alone, only gets you so far. Adding white, and even better, another tool for dedicated support material would be optimal. 6 tools seems like the logical minimum number for future printers. Snapmaker have started to become a more prominent voice in open source since releasing the U1, following Clippers and Orca's GPL and AGPL licenses. So it's attractive to those who want a more open source alternative, but one that is also more affordable than, let's be honest, a hefty Prusa Core 1 and Index purchase. But I wonder how well it will compete with other Chinese clones. While it would be possible, albeit quite challenging, to mod the U1 to accept an Index kit, it would be somewhat easier if Snapmaker open sourced the hardware. And I'm wondering whether the U1 will be the first affordable tool changer, and that's it. Perhaps my answer to whether the U1 will survive the Clone Wars will be offered very bluntly by Snapmaker in the form of the U1 Max. But I don't know. Right now, this printer, even with flaws, even without a top cover, is awesome. minimal purge waste, multi-material capability, native full spectrum control in the slicer, open source compliance. I can recommend it if you care about those things I just mentioned. But we are still left with the overbearing question. Should I wait for the next one?